Today we'll be learning about chemical reactions. Fun part of chemistry. So there are five signs of chemical reaction. So we covered this earlier in the year. I'll slide myself up a little bit so you can see. Sorry, kitty. Guess I'll slide this way. Okay, so number one, does it give off light? That's a sign. Just because it's a sign doesn't mean it's a chemical change. I turn the lights on, that is not a chemical change. But burning something is. Temperature change, that is fire. That is most definitely a temperature change, and that is definitely a sign of a chemical change. Production of a gas, also a sign. Formation of a precipitate. What's that? Well, that's when it gets cloudy. We'll see a whole bunch of precipitates later. So you'll see making a precipitate. And then, look, a color change. So these are all signs. If you see a sign or more than one sign, that is a good sign that there is a chemical change, but does not mean that there is one. So just keep your eyes open for the sign. Okay, so, I told the chemistry joke and, there was no reaction. Love my kitty videos. Okay, so, looks like my arrows are messed up. Okay, so we have chemical equations. Look, we have the things on this side. These are the reactants. And we have things on this side. Those are the products. We put a little arrow, this guy's a little misplaced, but we put an arrow in between to show the direction of the reaction. For now, the direction is only going to the right. For now, but just follow along, please. Thank you. That's equilibrium later. Okay, so now, if we just have a plain sign, a little arrow like that, that's what means just yields, forms products, reacts to, the usual stuff. We have the plus symbol, so this plus that equals this plus that. If we have that upcoming double arrow, that's for reversible, equilibrium, later. This is if we have some kind of catalyst, which we'll talk about that later. And this also shows that a triangle means we have to add heat to it to make it go. So these are just little things that might be on equations, but just the one that we're going to see right up front is the single arrow, meaning it goes. Then we have little subscripts, those little things afterwards. We have S, that means it's making a solid. L, which means it's a liquid. G, which means a gas. And AQ, if you remember, that's aqueous, dissolved in water. And then we have a PPT, which stands for precipitate. So that's kind of easy to remember. Solid, liquid, gas, aqueous, dissolved in water, and precipitate, PPT. Okay, so there are five common types of chemical reactions. They are synthesis, decomposition, single replacement, double replacement, and combustion. Sometimes you'll see different words for these, like single displacement, double displacement, instead of synthesis, combination. They're just different words for the same thing. So just be aware that those words are out there. So here's an example, and we love our friend Mario. So here is baby Mario and a toad, and then, oh no, they synthesize, meaning they come together to make a big Mario. So A plus B, that's the generic formula, makes AB. An actual formula would be carbon plus oxygen makes carbon dioxide. That is synthesis. Two things coming together. Easy. Decomposition is the opposite. Boink. Decomposition is where we have one thing breaking up into two things. So look, it's the exact opposite. AB goes into A plus B, as compared to here, A plus B makes AB. So synthesis is coming together. Decomp is breaking apart. They're opposites. Here we have a poorly written formula, and it breaks up into chlorine and Na. So that's breaking up. Okay, single replacement, one goes in and one comes out. So here we have Luigi and Yoshi hanging out together. They are one together. And then what happens is Mario comes in and says, "It's my turn." So now Luigi is on the side and Mario gets to ride Yoshi. So single replacement. One goes in, one comes out. So here is the generic A plus BC makes AB plus C. So A went in, C came out. Here we have CuCl2 and aluminum goes to aluminum and Cu. Notice the metal, aluminum, went in and then the Cu, copper, came out. So we will, don't worry about the balancing equations and little numbers afterwards. We'll deal with those later. But for now, notice one in, one out. Very common, it's going to be a metal. We'll talk about that later. Then we have a double replacement. Oh, look, they're going on a date, and they're going on a date, and they're like, "Hey, let's switch dates, whee!" So that's what they did, double replacement. That means A and B, they do-si-do, they switch partners. So A and B plus C and D makes AD and CB. So very frequently, these are precipitation reactions, which we'll spend more time talking about later. But notice, where'd it go? We have two things plus two things make two things plus two things. A double replacement. Two makes two.